This is section 4.1, part 2, and we're going to be doing some problem solving with inequalities now that we've got the basic of inequalities down. So the first thing we're going to do for these notes is write down some important words and phrases that you guys might hear. I'm going to go through what they mean, but I want to point out here that it's best not to just try and memorize which inequalities go with these phrases, but really just think about it in your head each time. So the first phrase I want to look at, important word or phrase, is if we see the word at least. And I'm always going to try and use the number 6 here. So let's say we saw that something was at least 6. So the way we would write that in an inequality is, since it has to be at least 6, it means the smallest it can be is 6. So we're going to use the variable k. The smallest it can be is 6. Can't be any lower. So it must be greater than 6. Now you want to think about, could it be 6? Well, if I said you're at least 6 years old, you could be 6 years old. So k is greater than or equal to 6. This is the same way as saying k is at least 6. It could be bigger than 6, could be 6. Greater than or equal to. The second phrase I want to look at is the phrase at most. So let's say we said that k is at most 6. So the biggest k can be a 6. So in this case, our k can't be any greater than 6, so it must be less than 6. If it's at most 6, then it could be 6. We want to put the or equal to under it. So if you can kind of hear about how I'm thinking about these in my head, that's what you want to do. You don't want to necessarily just memorize all of these. Oh, I meant to do that in blue. Our next phrase is cannot exceed. So if we said k cannot exceed 6, that means k could go up and up and up and up and up, but it could just never get any bigger than 6. So it must be all the numbers less than 6, and it could be equal to 6. If we say something can't exceed 6, it could go right up to 6, but it can't be greater than it. Our next phrase is must exceed. So if I said something must exceed 6, like k has to exceed 6, well then k has to be bigger than 6. If it must exceed 6, then it can't be 6. I can't put the little or equal to under this one because it cannot be equal to 6. It must be greater than 6. Our next phrase is less than 6. This one's pretty easy because it's already kind of saying what symbol you should use. K is less than 6. K is less than 6. It cannot equal 6, it has to be less than 6. Our next one is similar. It is more than. So if I said k is more than 6, it's the same as saying k is greater than 6. K has to be something greater than 6. It cannot be 6. It has to be more than 6. Our next phrase is in between or is between. So I might say something like k is between. And let's say in this case we're using the numbers 3 and 6. So k is between the numbers 3 and 6. So in this one, we know k is going to be in the middle. It's got to be bigger than 3 and less than 6. And this is important here. If it says is between 3 and 6, that does not include 3 and 6. It's any number between those, but not including those. So we don't want to put the or equal to symbol next to the 3 or the 6. It's anything in between those. It could be 3.0000001, could be 5.9999999, could be a little bigger than 3 and a little less than 6, but it can't hit those numbers. If you want to include those numbers, you can say it's between 3 and 6 inclusive. That would mean it would include those numbers. Our next phrase is minimum. So let's say we said something like K is at minimum 6. That means the smallest K could be a 6. That's the minimum. So K must be greater than 6. And if I said the minimum is 6, it could be 6. So we want to put the or equal to. Our next phrase is at maximum. So if I said K is at maximum 6, then we know it can't go any bigger because the max is 6. So it has to be less than 6. But if I said the maximum number it could be is 6, it could be equal to 6. So you want to put the or equal to under it. We have 2 more phrases to do. Our second to last one is no more than. So if I said K is no more than 6, that means K has to be less than 6. But if I just say it's not any more than 6, it could be 6, it's just not any more than 6. So K is less than or equal to 6 is the symbol for that one. And then our last phrase is no less than. So if I said something is no less than 6, I know it has to be bigger than it, but if I just said it can't be any less than 6. We know it has to be bigger than 6, but it could be 6. Like if I just said, don't bring any less than 6 cookies for me tomorrow, then you could bring me 6, but I'm just saying don't bring me any less than 6 cookies. All right, so we're going to do an example here. Go ahead and pause if you need more time to write that down. Here's our first example. I want you to translate this into an inequality. So our phrase is Angie earns no less than $12 per hour. Go ahead and pause if you need to write that problem down, if you need more time. The first thing I want you to do when we're writing an expression into an inequality is I want you to define a variable for me. Okay, that's your first step. You need to define a variable. That means pick a letter that you're going to use and tell me what it represents. So in my case, and here's how you're going to phrase it. I'm going to use the letter P. I'm going to say let P represent Angie's hourly pay. You could use like W and say it's her wage. I'm not going to mark off for which letter you pick as long as you make sure it makes sense. So you're going to say let blank represent blank. So you always want to have these words in it. Let something represent something else. I'm going to let P represent her hourly pay. We know she earns no less than $12 an hour. So her pay, P, has to be bigger than 12. No less than that. But it could be $12 an hour, so we want to put the or equal to under it. So this entire thing right here is our solution, because you need to define your variable, and then your second step is to write the inequality for it. I want you guys to try one of these on your own. It's going to be on the next screen. I want you to try this one on your own, and we'll check it in class. The number of volunteers was at most 20. So I want you to define a variable and then write your inequality. All right, we're going to do a sample problem right here. So it might be helpful right now to, maybe you don't want to write the entire problem, all the words down, but you need to write down what's important. Let's practice that together. So it says Jen can rent a moving truck for either $99 for unlimited mileage. So if I was doing this problem myself, I would probably go ahead and write down right now that we know one option is to rent it for $99, and that gives her unlimited miles. Or she can rent it for $49 plus 80 cents a mile. So I might write down, okay, she has another option to rent it for $49 plus 80 cents per mile. Those are her two options. For what mileages would the unlimited plan save more money? Okay, so I might write next to this to remind myself what the question was asking. For what mileage would this plan save money or be cheaper? That says money. I know it doesn't really look like it. Money. There we go. For what mileage would that plan save money? So that's what I might write down if it were me and I got this problem, because you want to remember what the problem was asking if you go back to study, but you don't necessarily have to write down every single word you saw. So what we want to do here is let's try and write an equation for each plan here. For this equation, or for this plan on limited miles, it's pretty easy. There's no equation. It's just $99. It's not 99 per mile. It's just $99 flat. That's our equation, 99. For our second plan, it's a little more complicated. It's $49 flat, plus we have to pay 80 cents per mile. So we might represent that like this, plus $0.8 or 80 cents for every mile. So we want to multiply that 0.8 by the number of miles. I'll let M represent the number of miles. Now I want to know, when is my unlimited plan going to cost less than my other plan? So I want to know, when is my $99 plan going to be less than my other plan, my 49 plus 0.8 M plan? I want to know when the unlimited one's going to save money, when it's going to be cheaper, so I want to use the less than symbol next to that sign, next to that equation. Now we can just solve this as we would any other equation. So we can draw a line through our inequality symbol. We're trying to get this M isolated by itself. So the first thing we want to do is subtract 49 from each side, because we have to undo our adding and subtracting first. From there, I'm left with 50 over here. I didn't multiply or divide by a negative, so I leave this a less than symbol. And on the right side of my equation, I'm left with 0.8 M. Now to get my M isolated or all by itself, the only thing I need to do is divide by this 0.8. It's a positive 0.8, so I don't need to flip my sign. And 50 divided by 0.8 is 62.5. I keep my symbol the same, and now I just have M over here. So this question, I want us to write it in a complete sentence. So if we look at what this means right here, here's our M. Our M is bigger. The alligator's eating it. So our M is greater than 62.5. So our number of miles has to be bigger than 62.5 for that $99 plan to be cheaper. So they said, when is it cheaper? We can say for mileages. Whoops, I almost said less than. Greater than, because our M is greater than. For mileages greater than. And I'm going to assume right here we can use half miles. 62.5 miles. So I'm going to put another word problem on the next screen. I want you guys to try it, and then we'll go over it in class tomorrow. Here's your problem. Bridgewater Legal charges a $250 retainer fee, so that's a one-time fee, for real estate transactions, plus $180 per hour. Now this other company, Dockside Legal, they charge just a $100 retainer fee, just once, plus they charge $230 per hour. I want to know, for what number of hours does Bridgewater charge more? When are they greater? So use the same process we just used. Okay, if you're not sure, at least try to write an equation for each. Try to set up an inequality, and then try solving it. Okay, I want you guys to at least try something here. We'll go over this one in class. and I will see you then.